Welcome back, Algebra 1 students. Taking a look at 3.4, solving multi-step inequalities. We have so far seen addition and subtraction with inequalities. We've also seen multiplication and division. Previously, we saw that we occasionally need to flip the sign when we're dividing or multiplying by a negative number. So that'll come back again as we begin to work with two-step inequalities and some multi-step inequalities. So the goal still remains that we're trying to solve the inequality, isolate our variable, and then graph. So we're going to utilize the SADMEP bit again, where the first step ideally is going to be to add or subtract, since this is a two-step equation, then multiply or divide, and then you go for exponents and whatnot. So first, let's get rid of this 6 because we're trying to isolate this t. So we are using subtraction just on this scenario. We're left with 3t, where it's now greater than 9. We're then dividing to get rid of this 3. No need to flip because 3 is positive. So this is saying that t is going to be greater than 3. We want an open circle on 3, and we want to highlight on the values that are greater than it. So this one's done. With the next part, what's intimidating about this? We have 2 parentheses t minus 1 plus 3t less than 2. What's intimidating about this? I don't think much, but I definitely think that we should go about getting rid of the parentheses. So let's distribute 2 to t, get 2t. 2 to negative 1 gets us negative 2. Rewriting plus 3t and negative 2. Is there anything that we can combine here? Anything that can be combined on the left side? Hopefully you notice that we have a 2t and a 3t, which we can combine together. Since they're both positive, we can get 5t, rewrite that negative 2. And then how can we go about it from here? Well, I think this can rely back on SADMEP. First, we can add 2 to both sides. This leaves us 5t where it's less than 4. Let's then divide by 5. No need to flip. So our inequality that we want here is going to be t where it's less than 4/5. So we want an open circle on 4/5, which is a little bit closer to 1 than 0, and we want to highlight on the values that are less than that. We see that sometimes we have two sides of the equation to balance, so this should recall your previous problem-solving skills on when you have equations on both sides of an inequality. So you have two sides to balance here. Let's take a closer look. You have that 4n plus t2, where it's less than or equal to 7n minus 13. So a little bit going on here, but nothing that you can't handle. So we recalled previously with problems like this that we should try and classify where the variables go. So good rule of thumb, put variables where the highest number of variables already are. That's a really good rule of thumb. It will make your life easier, you will stay organized, and you'll be successful. So I see 7n over here. I'm going to declare that this is where I want variables to go. On the left side is where I want constants to go. So I'm going to knock this out all in one step. So I'm trying to move 4n over here. I'm going to use subtraction because I want to think opposites. I then want to move the 13 over to the other side. 2 plus 13 gets you 15. This is less than or equal to 3n. We can then go about this using division on 3. 3 cancels. This is now 5 less than or equal to n. And we're done. get a closed circle on 5, throw that to the left, or no, throw that to the right actually, and we're done. So keep in mind, put variables where the highest number of variables are, the highest coefficient. The sooner you can declare that, the easier the problem will be. We'll see sometimes we have special solutions when we solve these. So first, distributing. Since we have parentheses, this is similar to problems we've already seen to get 14. So 2 times 7 gets you 14. 2 times -3n gets you -6n. And so you might notice that both sides of this equation are identical. If you try to isolate n, well, let's try it. Since both sides have the same number of n, we can just kind of shift terms around all over. We soon see that we're left with -6n is less than or equal to -6n. So with situations like this that are true on both sides, we can say that our answer is going to be all real numbers. Or infinitely many solutions, because both sides of these equations are similar, identical, if you will. On the right side, we can try again to combine what we can. So here on the right side, I see 9p and -5p. These happen to be on the left side, so I think it's a good rule of thumb to just combine them as is and say that this is going to be 4p plus 6. The previous strategy in the previous example said to focus on where the most number of variables are. Since these are equal on both sides, all you can really do is try and get rid of the 4p. Eventually, this leaves you with 3 where it's greater than 6. So think about this. Is this a logical statement? Is 3 really greater than 6? It's not. So since this is a false statement, we say that there are actually no solutions, or no solution. So that means that there's no number that if you were to plug into here is going to make a logical statement out of this equation. If you have any questions on this, email me. Pause the video, go back and try these now that you've seen them. If you have any questions, bring them to class or email me. Thanks for watching.